Dear students, welcome back. So today let's continue with the topic quadrilaterals. So under that, again we'll continue with the concept of properties of a parallelogram. So the last two concepts left. That is, the diagonal of a parallelogram bisect each other. The next one, if the diagonal of a quadrilateral bisect each other, then it is a parallelogram. So here when the first concept, the diagonal of a parallelogram bisect each other. So what is meant by diagonal? So diagonal, you should have the picture of a diagonal of a parallelogram bisect each other. What is meant by bisecting? So bisecting means dividing into two equal halves. So what is dividing here? Two diagonals are divided to two equal halves here. So that you have to know what it is, diagonal of parallel. So let's continue with the proof. So let us take a parallelogram. So we know that by the definition of parallelogram, it is a quadrilateral with opposite sides parallel. So given ABCD is a parallelogram. ABCD is a parallelogram. To prove, okay, to prove what we have to prove, let us have a diagonal AC and BD. Okay, let AC and BD be the diagonal. Diagonals. So what we have, do meet at O. Diagonals meet at O. So we have to prove that OA is equal to OC and OD is equal to OB. This is what we have to prove. So let's start with the proof. So since we have to prove this side is equal to this side and this side is equal to this side, with these two sides and with one of the opposite side, we get a triangle. So here also we have two triangles. So it's opposite also we have triangles. So let us take those two triangles. Either you can take these two triangles or you can take these two triangles to prove the bisection of the diagonals. Okay. So I'll take these two triangles. So from triangle AOB and triangle DOC, from these two triangles, since AB is parallel to AB, since AB is parallel to DC, it's a parallelogram, so opposite sides are parallel. So what we have, alternate interior angles are equal. This angle is equal to this angle, this angle is equal to this angle, right? So what do we have? So we have angle DOC is equal, sorry, not DOC. So we have angle OD. So ODC is equal to angle OBA, and we have angle OAB is equal to angle OCD. So this is what this is. Since they are parallel, so these are alternate interior angles, right? Okay. Next, what else we have? We know since it's a parallelogram, we have already proved that opposite sides are equal, parallel and equal. So we have DC is equal to AB. So it is given opposite sides will be parallel. Proved already. So therefore, which congruence rule criteria holds here? Angle, side, angle. Therefore, by ASA congruence rule, what you can say? Triangle DOC is congruent to triangle DOC, I said. So this 2 angle comes first, right? So it has to be, then goes O. So it will be BOA. Cannot take anything else here. I cannot take AOB because I've started with this angle. So it will congruency when you have talking about terms, it has to be the corresponding angle should be congruent, equal. So BOA. Therefore, by CPCD, what we can say? We can say that OC is equal to OA and OB is equal to OD. That means the diagonals of a parallelogram bisect each other. So the next is if the diagonal of a quadrilateral bisect each other, then it is a parallelogram. That means we are going in a reverse order. Same thing you will do. Here already these two will be given. So next one I will do it. So same thing. The given concept changes. Here ABCD is not a parallelogram. This everything differs. Same way, the proof is the same way. You are doing the congruency but not the angle, because here we are not saying it is parallel. We are saying the sides are equal, opposite sides are equal. I mean the diagonals bisect each other, we say, and it is a quadrilateral. So what is given here? ABCD is a quadrilateral, and diagonals of a quadrilateral bisect each other. What is given here? OD is equal to OB and OA is equal to OC is given. To prove ABCD is a parallelogram, as I have already told you, to prove parallelogram, we should have proved that opposite sides are parallel. So AB is parallel to BC and BC is parallel to DA, we have to prove. So we'll start with the proof. So again we are going to take the same triangle. So from triangle, so what we have done there, we have proved the alternating interior angles are equal. So once you prove alternating interior angles are equal, then those two lines has to be parallel. So from triangle DOC and triangle AOB, we already have this thing. OD is equal to OB, OA is equal to OC. These are given things. Yes, these are given. This is already given. Now, this angle is equal to this angle. Why? Because that's a vertically opposite angles. Two lines are intersecting. So we are using vertically opposite angle concept. So it is angle DOC is equal to angle AOB. So reason is vertically opposite angles are equal. So what do we have now? This side, this angle, this side. So which congruence rule? By SAS. Therefore, by SAS congruence rule. This rule, what you can say? Triangle, which triangle? DOC. DOC is congruent to triangle, which triangle? This two side comes. So it will be DOE. Triangle DOE. So we have proved the congruency. Once you prove the congruency, again by CPCT, we can prove that the alternate interior angles are equal. This angle is alternate. This and these two are alternating. And these two are also alternate interior angles. If you prove one alternate interior angle, therefore by CPCT, we can prove that angle CDB is equal to angle DBA. DBA. So that is by alternate interior. These are alternate interior angles. Yes. So if this is equal, so these two are equal, therefore what you can say, AB is parallel to DC. Similarly, you can prove that this angle is equal to this angle, taking this as a transversal. So you get AD is parallel to BC. Okay. So this is the proof of those two theorems, that is diagonals of a parallelogram bisect each other. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So to prove parallelogram, we have to prove find the alternative interior angles are equal. Then we have to prove that alternate interiors are equal. Once we prove alternate interior angles equal, then those two, where those alternate interior angles are formed, right, with the transversal, those two lines will be parallel. Yes, so that's all for the today's in this session. So we'll continue with the concept of quadrilateral in the next session. So, okay, thank you.